Hello, I welcome you all to this another interesting screencast. The problem reads at the instant theta equal to 60 degrees, the boy's center of mass g has a downwards speed vg equal to 15 feet per second. Determine the rate of increase in his speed as the acceleration is asking us to find the tension in each of the two supporting cables of the swing at this instant. The boy has a weight of 60 pounds and neglect his size and the mass of the seat and the cords. And in the second problem, it reads the same. Here we have been asked to determine the speed and the tension in each of the supporting cables of the swing when theta is equal to 90 degrees. The boy has a weight of 60 pounds, neglect his size and the mass of the seat and the cord. Alright, this problem is, both problems are coming from the Engineering Mechanics and Dynamics 14th edition by R.C. Hibbeler. So we are going to only solve one problem in this particular case, which is the first case. Let's draw the free body diagram. So we'll do a section. Let's do a section there like so. And once we do the section, then it means we are going to have some tension force. We'll have tension force in this, okay, and this like so, okay. What else? We have the weight. We do have the weight of this child, and the weight is always vertical. Okay, the weight is always vertical. Let me use this color. The weight is always vertical. So there we go. Okay, not a very good color, not very visible. Maybe we try blue. Okay, sorry about that. Alright, I think better. There we go. What else do we have? Of course, we have this coordinate here. We have two coordinates here that we're dealing with. We do have this coordinate, which is the normal coordinate, positive going up like this, and we do have another coordinate in this direction, which is perpendicular to the normal, and this is our end coordinate. Okay, let me not make it too long. Just like that is enough, so that I have space for other things. Okay, so let's call this T coordinate. We call this N coordinate. So this W is going to have components. This W will have components. This is W, okay, which is just equal to mg. Okay, we can leave it like that. This is W, which is equal to mg. All right, so we are going to have components from this W. If I was to draw a vertical line like this, okay, if I did that, then we know that this is our theta here, okay, and if this is our theta, then this one here becomes 90 minus theta, and then this one here, this other one here, this direction here becomes theta. This becomes theta also here, okay, right? So if that is the case, then let's redraw this properly. Redraw this properly. All right, so along this direction, let me extend the T. Let me extend the T like so. Extend it something like so. Great. So this angle here is our theta. So we are going to have two components. We'll have one component in this direction like so, okay, all right, and then we'll have another component in this direction like so. All right, is that fine? course it should be fine. Right, so let's label them. So like we said, this is our tension. All right, then this one is equal to this one. This component is equal to W. How come here I can't see the G? W is equal to, this is equal to W sine theta, and then this one is equal to W cos theta. Let me make mention to say here the cables are two. Okay, the cables are two. This is what I said for each of the two supporting cords. So the cables are two here, so we'll say 2T 2T. Okay, so let's go to case 1 quickly. We go to case 1, which is just 1360. We write down the equations of motion. Let's start with the N. So we have summation of forces in the N direction equal to MAN. Going up, there have been our reference positive. Our AN is just equal to V squared divided by rho. So what do we have in that direction? So we have 2T minus W sine theta, and this is just equal to MAN, which is equal to M V squared divided by rho. And we know what all these are. Let's replace them. So let's make T subject to the formula. Our T therefore will just be equal to M V squared divided by rho plus W sine theta, and then of course everything we are going to multiply by 1/2. So this is just going to be equal to 0.5. Okay, 0.5. Then we have the mass, which is 60 divided by 32.2, 60 pounds. We are dividing it by the acceleration due to gravity in feet per second squared. Then we have 15 squared divided by rho. Rho is 10. Okay, and then plus W itself is just 60, and then sine the angle is 60 degrees. So we have this equation. Therefore our T is just going to be equal to 16 divided by 32.2 times 15 squared divided by 10, and plus 60 sine 60, right, then by 0.5. So this we get a 46.94, 46.94 pounds. Okay, right. So I think we are done with the first case. Let's move on to the next case. Summation of forces in the T direction equal to MAT, and then going down, this is our reference positive. What do we have in that direction? We do have W cos theta equal to MAT. Of course, the idea here is to find AT, which is the tangential acceleration. This is just going to be equal to W cos theta divided by M, and this is equal to 60 cos 60 degrees divided by 60 divided by 32.2. Right, so this and this can cancel out, 32 can go up, and cos 60 is 0.5. Therefore our AT is just going to be equal to 16.1 feet per second squared. I think this is about it. We found the tension which is a 46 point in each cable, that is, and then we found the rate at which the speed is increasing. I hope this video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and I'll see you in my next screencast.